This is video 10 in the C8 rates and equilibrium topic. This is the last video of the topic, and what we're going to look at is how we make fertilizers in industry. So when we're looking at industrial production of fertilizers, you will notice that it's on a very large scale and in an integrated process. What we mean by an integrated process is when loads of different reactions are happening on the same site at the same time, and then they are feeding into one another. And I will show you what an industrial integrated process looks like later on in this video. The reason we are going to do something like this, where we have many reactions happening and they all provide each other with something, is because it actually allows for what we call a continuous process. And that means you can keep the reactions going without having to stop them and restart them. But it also means you can produce huge amounts of what you're trying to make quickly. And so you make more profit because of that. In industrial fertilizer production, we have to mine some of our reactants. So these reactants are things like phosphate rock, potassium chloride, and potassium sulfate, which exist as rocks in the ground. And these solid chemicals are obtained by digging or mining the rocks directly from the ground, then processing them to purify them before we use them in our process. So why are we doing this? Well, the whole aim of this is to create fertilizer salts. So our potassium chloride and our potassium sulfate salts are mixed with our fertilizers that we're going to make from our plants to make an important chemical, NPK fertilizers. NPK fertilizers are used by farmers around the world to feed their crops to encourage growth. So how does this work? So our phosphate rock is treated with different acids to produce our different fertilizers, okay? So the first one we're going to look at is if we treat it with nitric acid, we produce two products. We produce phosphoric acid, which we're then going to use later on in the process, this integrated process. We're making something we're going to reuse, and calcium nitrate. And the calcium nitrate is one of our salts. The phosphoric acid is then reacted with ammonia in a neutralization reaction to produce ammonium phosphate. This is another one of our fertilizer salts. This is one of the key ones. This is one that we will use later on to make our NPKs. Phosphate rock can also be treated with sulfuric acid, and it will produce something called single superphosphate. And single superphosphate is a mixture of calcium phosphate and calcium sulfate. And both of these are, as I said before, our salts that we're going to use either in part of the process or in making our fertilizers later on. And then the final thing that our phosphate rock undergoes is we actually react it with some of the phosphoric acid that it produces earlier in the process to produce triple superphosphate. And triple superphosphate is calcium phosphate. Okay, guys. So why are we doing this? Why are we using a humongous process like this? And why wouldn't we do it in the lab batch process like you learned in previous videos? Well, lab batches are good if we want to make smaller amounts of substances such as our fertilizers, and they don't cost very much to set up. But the problem with a lab batch is that you need a lot of people to actually work in the production line. Each person has to perform the reaction themselves. So if you want to make a lot of it, you're going to need hundreds, if not thousands, of people to do this. Our problem with that is because people are working directly with the chemicals, you can only really use dilute solutions for safety reasons. So you can't make huge amounts of chemical with high concentrations for safety. And you're going to have to shut down a lot to clean or maintain your equipment. So you will only probably be able to do a process maybe once or twice, and then you'd have to do a big deep clean and then move again and set it all up again to go. Industrial processes are the opposite of this. They produce huge amounts of fertilizer in very quick time frames. The problem is it costs quite a lot to set them up, because you obviously need to buy a lot of equipment and build huge buildings and buy a lot of your raw materials to do this. But when you've got it set up, it requires few people to actually work in production. They more monitor the processes than actually perform the reactions. You only have to shut down very rarely to clean or maintain your buildings. And you can use hazardous conditions that you can't do in other settings. The only issue we have with that is sometimes those hazardous conditions can cause explosions and death. And remember that high setup cost I talked about? This is one of the reasons for it. The equipment used needs to be made of strong stainless steel to withstand very high pressure and possible corrosion from our acids, which are at high concentrations. So we have lots of cost, but because it's producing these huge amounts, actually we make a lot of profit from continuous rather than batch processes. So I spoke to you earlier about our integrated industrial processes. This is how we integrate all of our production in terms of the chemicals that would come from our fertilizers. So here's our mined phosphate rock. And our mined phosphate rock can react in 3 different ways. We can react it with with nitric acid, which will produce phosphoric acid and calcium nitrate. We can react it with the phosphoric acid down here to produce our triple superphosphate. Or we can break it down with other things like we've done before and produce our single superphosphate. Our phosphoric acid can react with ammonia to produce ammonium phosphate, which would produce our NPK fertilizers when we mix it with a mined potassium chloride rock. The Haber process will feed into this process that you've learned before in video 7 by producing the ammonia that we're going to use in the process. And this ammonia can then be turned into nitric acid or reacted with nitric acid that it's also used to make to produce ammonium nitrate. This one here, this one here, this one here, and this one here, they are all turned into fertilizers or salts of some sort that we can sell. Hey guys, thank you for watching the video. This is the last video on the topic. I will be back again soon with another topic.